What is an eclipse of the moon? What causes eclipses and why? How often do eclipses happen and when is the next eclipse of the moon? You'll learn the answers to these questions and more in Eclipses Primer on lunar eclipses. The moon is a cold, rocky body about 2,160 miles 3,476 kilometers in diameter. It has no light of its own but shines by sunlight reflected from its surface. The moon orbits Earth about once every 29.5 days. As it circles our planet, the changing position of the moon with respect to the sun causes our natural satellite cycle through a series of phases: new moon greater than new crescent greater than first quarter greater than waxing gibbous greater than full moon greater than waning gibbous greater than last quarter greater than old crescent greater than new moon. Again, phases of the moon. The phase known as new moon cannot actually be seen because the illuminated side of the moon is then pointed away from Earth. The rest of the phases are familiar to all of us as the moon cycles through them month after month. Did you realize that the word month is derived from the moon's 29.5-day period? Many early civilizations used the moon's monthly cycle to measure the passage of time. In fact, some calendars are synchronized to the phases of the moon. The Hebrew, Muslim and Chinese calendars are all lunar calendars. The new moon phase is uniquely recognized as the beginning of each calendar month, just as it is the beginning on the moon's monthly cycle. In comparison, the full moon phase occurs midway through the lunar month. The full moon is popularly known as the phase of love and romance. When the moon is full, it rises at sunset and is visible all night long. At the end of the night, the full moon sets just as the sun rises. None of the moon's other phases have this unique characteristic. It happens because the moon is directly opposite the sun in the sky when the moon is full. Full moon also has special significance with regard to eclipses. Geometry of the sun, earth and moon. During an eclipse of the moon, Earth's two shadows are the penumbra and the umbra. Sizes and distances not to scale. Types of lunar eclipses. An eclipse of the moon or lunar eclipse can only occur at full moon, and only if the moon passes through some portion of Earth's shadow. That shadow is actually composed of two cone-shaped components, one nested inside the other. The outer or penumbral shadow is a zone where the Earth blocks part but not all of the sun's rays from reaching the moon. In contrast, the inner or umbral shadow is a region where the Earth blocks all direct sunlight from reaching the moon. Astronomers recognize three basic types of lunar eclipses. The moon passes through Earth's penumbral shadow. These events are of only academic interest because they are subtle and hard to observe. Click for photo example. A portion of the moon passes through Earth's umbral shadow. These events are easy to see, even with the unaided eye. Click for photo example. The entire moon passes through Earth's umbral shadow. These events are quite striking due to the moon's vibrant red color during the total phase totality. Click for photo example. Now you might be wondering, if the moon orbits Earth every 29.5 days and lunar eclipses only occur at full moon, then why don't we have an eclipse once a month during full moon? I'm glad you asked. You see, the moon's orbit around Earth is actually tipped about 5 degrees to Earth's orbit around the sun. This means that the moon spends most of the time either above or below the plane of Earth's orbit. And the plane of Earth's orbit around the sun is important because Earth's shadows lie exactly in the same plane. During full moon, our natural satellite usually passes above or below Earth's shadows and misses them entirely. No eclipse takes place, but 2 to 4 times each year, the moon passes through some portion of the Earth's penumbral or umbral shadows, and one of the above 3 types of eclipses occurs. When an eclipse of the moon takes place, everyone on the night side of Earth can see it. About 35% of all eclipses are of the penumbral type, which are very difficult to detect, even with a telescope. Another 30% are partial eclipses, which are easy to see with the unaided eye. The final 35% or so are total eclipses, and these are quite extraordinary events to behold. What is the difference between a lunar eclipse and a solar eclipse? A solar eclipse is an eclipse of the sun. It happens when the moon passes between the Earth and the sun. This is only possible when the moon is in the new moon phase. For more information, see Solar Eclipses for Beginners. Total lunar eclipse of 2004, October 27-28. Beginning right, middle, center and end left of totality. Click to see photo gallery. Why is the moon red during a total lunar eclipse? During a total lunar eclipse, the Earth blocks the sun's light from reaching the moon. Astronauts on the moon would then see the Earth completely eclipse the sun. They would see a bright red ring around the Earth as they watched all the sunrises and sunsets happening simultaneously around the world, while the moon remains completely within Earth's umbral shadow, and direct sunlight still manages to reach and illuminate it. However, this sunlight must first pass deep through the Earth's atmosphere, which filters out most of the blue-colored light. The remaining light is a deep red or orange in color and is much dimmer than pure white sunlight. Earth's atmosphere also bends or refracts some of this light so that a small fraction of it can reach and illuminate the moon. The total phase of a lunar eclipse is so interesting and beautiful precisely because of the filtering and refracting effect of Earth's atmosphere. If the Earth had no atmosphere, then the moon would be completely black during a total eclipse. Instead, the moon can take on a range of colors from dark brown and red to bright orange and yellow. The exact appearance depends on how much dust and clouds are present in Earth's atmosphere. Total eclipses tend to be very dark after major volcanic eruptions since these events dump large amounts of volcanic ash into Earth's atmosphere. During the total lunar eclipse of December 1992, dust from Mount Pinatubo rendered the moon nearly invisible. All total eclipses start with a penumbral followed by a partial eclipse, and end with a partial followed by a penumbral eclipse. The total eclipse is sandwiched in the middle. The penumbral phases of the eclipse are quite difficult to see, even with a telescope. However, partial and total eclipses are easy to observe, even with the naked eye. Total lunar eclipse of 2000 January 2021 beginning right, middle center and end left of totality. Click to see more photos observing lunar eclipses. Unlike solar eclipses, lunar eclipses are completely safe to watch. You don't need any kind of protective filters. It isn't even necessary to use a telescope. You can watch the lunar eclipse with nothing more than your own two eyes. If you have a pair of binoculars, they will help magnify the view and will make the red coloration brighter and easier to see. A standard pair of 7 by 35 or 7 by 50 binoculars work fine. Remember to dress warmly and enjoy the spectacle. Amateur astronomers can actually make some useful observations during total eclipses. It's impossible to predict exactly how dark the moon will appear during totality. The color can also vary from dark gray or brown, through a range of shades of red and bright orange. The color and brightness depend on the amount of dust in Earth's atmosphere during the eclipse. Using the Danjon brightness scale for lunar eclipses, amateurs can categorize the moon's color and brightness during totality. Another useful amateur activity requires a telescope. Using a standard list lunar craters, one can carefully measure the exact time when each crater enters and leaves the umbral shadow. These crater timings can be used to estimate the enlargement of Earth's atmosphere due to airborne dust and volcanic ash. Of course, an eclipse of the moon also presents a tempting target to photograph. Fortunately, lunar eclipse photography is easy provided that you have the right equipment and use it correctly. See Merclipse's pics for camera, lens and tripod recommendations. For more photographs taken during previous lunar eclipses, be sure to visit Lunar Eclipse Photo Gallery. Lunar eclipse frequency and future eclipses. Penumbral eclipses are of little interest because they are hard to see. If we consider only partial and total lunar eclipses, how often do they occur during the 5,000-year period from 2000 BCE through 3000 CE? There are 7,718 eclipses of the moon, partial and total. This averages out to about 1.5 eclipses each year. Actually, the number of lunar eclipses in a single year can range from 0 to 3. The last time that 3 total lunar eclipses occurred in one calendar year was in 1982. Partial eclipses slightly outnumber total eclipses by 7 to 6. The table below lists every lunar eclipse from 2014 through 2020. Click on the eclipse date to see a diagram of the eclipse and a world map showing where it is visible from. Although penumbral lunar eclipses are included in this list, they are usually hard to see because they are faint. The umbral magnitude is the fraction on the moon's diameter immersed in the umbra at maximum eclipse. For values greater than 1.0, it is a total eclipse. For negative values, it is a penumbral eclipse. The eclipse duration column lists the length of the partial eclipse in hours and minutes. If it is a total eclipse, 2 values are given. The first is the amount of time between the start and end of the partial phases, while the second in bold is the length of the total eclipse. Eclipses of the moon. 2014-2020 date. Eclipse type. Umbral magnitude. Eclipse duration. Geographic region of eclipse. Visibility 2014 April 15th. Total 1.29103 h 35 meters 01 h 18 meters Aus. Pacific Americas 2014 October 8th. Total 1.16603 h 20 meters 00 h 59 meters Asia Aus. Pacific Americas 2015 April 4th. Total 1.00103 h 29 meters 00 h 05 m Asia, Aus, Pacific, Americas 2015 September 28 total 1.27603 h 20 meters 01 h 12 meters E Pacific, Americas, Europe, Africa, W Asia 2016 March 23 penumbral 0.312 Asia, Aus, Pacific, W Americas 2016 September 16 penumbral 0.064 Europe, Africa, Asia, Aus, W Pacific 2017 February 11 penumbral 0.035 Americas, Europe, Africa, Asia 2017 August 7 partial 0.24601 h 55 meters Europe, Africa, Asia, Aus. 2018 January 31 total 1.31503 h 23 meters 01 h 16 meters Asia, Aus, Pacific, WN America 2018 July 27 total 1.60903 h 55 meters 01 h 43 meters S America, Europe, Africa, Asia, Aus. 2019 January 21 total 1.19503 h 17 meters 01 h 02 m C Pacific, Americas, Europe, Africa 2019 July 16 partial 0.65302 h 58 meters S America, Europe, Africa, Asia, Aus 2020 January 10 penumbral 0.116 Europe, Africa, Asia, Aus 2020 June 5 penumbral 0.405 Europe, Africa, Asia, Aus 2020 July 5 penumbral 0.644 Americas, SW Europe, Africa 2020 November 30 penumbral 0.262 Asia, Aus, Pacific, Americas Geographic abbreviations used above N North, S South, East, W West, C Central for an extended version of this table, see Lunar Eclipse Preview 20,112,030. Upcoming lunar eclipses visible from the USA include total lunar eclipse over Maui. A Nikon 8008 was used in multiple exposure mode to capture the entire eclipse on one frame of film. A second exposure captures morning twilight. Total lunar eclipse of 2000 July 16 Lahaina, Maui. Click to see larger image.